Hi everyone. Today we will discuss conditional probability, lesson 6 with a different example. Again, probability of B given A means probability of A and B divided by probability of A. Okay, and the probability of A can be rewritten as probability of A and B plus probability of A and not B. Okay, so before solving our regular question, let me give you very simple diagram. Now, if you have a two event A and B, and this is the total one, and let me fill out some number here. So 3 is here, for example, 2 is here, 5 is here, and 10 is here. From this example, I hope you understand what does each number means. For example, number of set A will be 3 plus 2. Can you see that? This is a 5. Now number of event B is a 2 plus 5 or 7, and number of the total one, if you add all of this number, this will be 20. Okay, and so on. Now if I want to find the probability of A given B, if we are given this type of Venn diagram, this is quite an easy situation, right? Because given B means in this picture, yeah, this circle is our given number. So this is 7. And we need event A. In this circle, event A means this one, right? This is 2. This is the answer. But if we don't have this type of Venn diagram, we must find this value algebraically, right? So if I copy one more time, this one is number of event A and B over number of event B. Okay, this is 2 over 7. And one more situation, if this number, this expression was not given, then we must use here. If you divide this one is n over u divided by n over u, now that is the same one as a probability of A and B divided by probability of B, right? We use all probability. Now, what is the probability of A and B? Here, number of A and B is 2. So probability of that situation is 2 over 20, right? And number of B is 7 here. So probability of B will be 7 over 20. And we easily know that this is the same as 2 over 7. Okay? Okay, we will start to solve a real world problem. Of the daily output, machine A and B produce items of which 2% are defective. Okay, here machine A defective 2%, and B also 2% defective 2%, while machine C, wow, we have one more machine here, produce items of which 4% are defective, so defective 4%. Okay, machine B and C produce the same number of items, while machine A produces twice as many items as machine B. Okay, so if B and C produce the same number, so if machine B produces one item, C produces also one item, and machine A produces twice as many as B, so this is 2. Is okay? So the probability that, for example, if you choose an item, what is the probability that that item was made by machine A? This is 2/4, correct? And machine B has a probability of 1/4, and machine C probability of 1/4. Okay, do you understand the meaning of this one and meaning of this one? Excuse me. So question: an item selected and is found to be defective, find the probability that it came from machine B. Okay, let me make some tree chart first. First, A, B, C. If I use all decimal, the probability that an item was made by machine A is 2/4 or 0.5, right? And machine B, or 0.25, machine C, or 0.25. Is okay? Now from machine A, defective is 2%. From machine B, defective is 2%. And machine C, defective is 4%. So from the situation, what is the probability? Is A and D. You can simply multiply these two numbers, right? This and this, which is 0.010. Is okay? Now probability of machine B and defective, again you can simply multiply these two numbers, 0.005, and probability of machine C and defective, you multiply these two numbers, which is 0.010. Okay, and the question asks us probability that the defective item came from machine B. So can you write the equation? B, right, given D. Good. This is our conditional probability. So this is the same as probability of machine B and defective divided by probability of defective. So probability of B and D was here, so 0.005, And probability of defective are all sum of all of this one, right? So this is 0.010, 0.005, 0.010. Simply, this is if you multiply by 1000 to the numerator and denominator, this will be 5 over 25 over 1 over 5 over 0.2 or 20%. Is okay? Again, let me copy the conditional probability one more time. You need the probability of A given B. Then please try to find the probability of A and B and divide by probability of B. Okay? We can find the totally opposite situation. Probability of B given A equals probability of B and A divided by probability of event A. Okay? Okay, thank you for watching. I hope we can see together another time with a different example for conditional probability. Okay, bye-bye.